Today I'm going to present our mini project with the title Hand Calculation Analysis of a Bus Stop Bench Support Under Human Loading. I'm from Section 3, Group 36. Before I move along, allow me to introduce myself. My name is Chai Cheng Gang with the number matrix CD2402886.
Hi, my name is Deton Dewan Adiki and my matrix number is CD240186.
My name is Desmond Edian Aziz and my matrix number is CD240129.
My name is Direk Nadang Anompo, matrix number CD240216.
Salutation, my name is Justin Blair Nabalin. My matrix number is CD240221.
I'm going to present with the introduction. Beams are fundamental structural elements that carry loads primarily through bending and shear. Using solid mechanics principle, complex real-world structure can be idealized as a beam models to estimate the internal force, stresses, and also deflection through the hand calculation. In this mini project, a bus stop bench is used as a practical example of a beam-supported structure. This sitting plank is supported by legs across onto the ground, allowing it to modelize as a simply support beam. Under use, the bench subjected to its self-weight and human loading, which induce bending and internal stresses. The objective of this analysis is to evaluate the structural behavior of a bench under realistic loading condition by calculating reaction force, shear force, bending moment, stresses, and deflections. These results are compared with the material strength to assess the safety of the structure while acknowledging the assumption and limitation of the model.
And now let's talk about the theory. A beam resists transverse load mainly through building many everyday structures such as benches and shelves can be idealized as beam to simplify analyze using solid mechanics. In this study, the bench support is modeled as a beam supported at discrete points, allowing the internal forces, stresses, and deflections to be analyzed using classical beam theory. For a beam in static equilibrium, the sum of all forces and moment must be zero. Fx equal to 0, Fy equal to 0, and moments equal to 0. These equations are used to calculate reaction forces at the support under applied loads. The third, transverse loading generates internal shear forces and bending moments along the beam. Shear force and bending moments diagrams are used to identify the critical section where maximum stresses occur. The fourth, bending stresses in a beam is calculated using the flexure formula. Stress equals to my divided by I. Maximum stress occurs at the outermost fibers of the beam. The beam deflection is the vertical displacement caused by loading. According to Euler's Bernoulli beam theory, EI d square V divided by dx square total sum over equals to mx. Deflection limits are important for serviceability and user comfort. Material properties such as Young modulus and yield strength control beam behavior. Structural safety is assessed using a factor of safety. Factor of safety equals to yield strength divided by maximum working stress. A factor of safety greater than 1 indicates safe performance under applied loads. That's all from me. Thank you.
Okay, so for methodology is the bus stop bench is idealized as a simply supported prismatic beam supported by vertical legs. The bench is assumed to behave elastically under static loading following Euler-Bernoulli beam theory. So material is considered homogeneous and isotropic with dynamic effects, vibration, temperature change, and fatigue neglected. So for geometry and material properties, bench span length and cross-sectional dimensions are defined. Material properties such as Young's modulus and yield strength are identified. Sectional properties including second moment of area, section modulus, and cross-section area are calculated. So stress Deflection and safety evaluation is static equilibrium equations are used to calculate reaction forces. Shear force and bending moment diagrams are developed to identify critical sections. Bending stress is calculated using the flexure formula. Deflection is determined using standard beam deflection equations. Calculated stress and deflections are checked against material limits and severability criteria. Loading and structure analysis. Human loading is modeled using a design weight on 75 until 100 kg per person. So loads are converted to force using gravitational acceleration. Loading is ideally as a uniformly distributed load or a concentrated load at mid-span to represent worst-case conditions. A free body diagram is drawn to show applied loads and support reactions.
So for free body diagram part, for our bus stop bench support, so the bus stop bench support is idealized as a simply supported beam that is exposed to human loading in steady free body diagram. The equally distributed load operating along the bench length is depicted in the diagram as the result of both the structure, self weight, and the weight of its occupants. To show how the applied loads are securely transferred to the ground, reaction force at the support are also displayed, because it makes it possible to determine reaction forces, shear forces, bending moments, stresses, and deflection. The FBD forms the basis for further hand calculation.
Now, I will explain 5.0 hand calculation. Before we start the calculation, we assume that the bench is modeled as simply supported beam and the span length is 1.8 meter, number of users 3 persons, average mass per person 75 kg, and the Young modulus for mass steel is 200 gigapascal, yet strength equal to 250 megapascal. So for the cross section, for this rectangular steel beam, the width equal to 0.05 meter and the height is 0.005 meter. Okay, for the calculation, first one, we must use the summation Fy equal to 0, Ma equal to 0. So for the final answer, we found that the value of Ra equal to Rb, that is 1103.62 Newton. Number 2, total human load is equal to M times G. So the answer is 2207.25 Newton. And the uniform distributed load is weight over length. So the answer is 1226.25 Newton over meter. And the third one, for finding the maximum bending stress, the formula is WL square over A. So the answer is 496.63 Newton meter. For the bending stress calculation, the second moment of area is BH cube over 12. And the answer is 5.21 times 10 power by negative 10 meter power 4. For the bending stress, the formula is equal to My over I, and the answer is 23.8 megapascal. For the maximum deflection, the formula is 5W times L power by 4 divided by 384 EI. So the answer is 1.6 millimeter. And the last one, the factor of safety equal to maximum deflection over yield strength equal to 10.5. So, for the conclusion of hand calculation, the 10.5 is the computed factor of safety, which is much higher than unity. This shows that the material yield strength is far higher than the maximum bending stress caused by human loading. Finally, under the presumptive service circumstances, the bench construction is regarded as safe and dependable.
And now for the discussion. The hand calculation analysis shows how the bus stop bench behave structurally under human loading model as a simply supported beam using classical beam theory. The reaction force at both support are equal due to uniform loading, indicating balance and stable load transfer to the bench leg. Maximum bending moments occur at a mid-span consistent with theoretical prediction for simply supported beams. Bending stress is well below the yield strength of mild steel with a high factor of safety, 10.5, confirming the bench is structurally safe and capable of handling heavier or uneven loads. Deflection under human load is within acceptable limits, ensuring both comfort and serviceability. Limitation. Analysis assumes static loading, ideal support, and uniform materials such as dynamics, effects, joint flexibility, imperfection, and fatigue are not considered, which may affect real-world performances. And that's all from me. Thank you.
Now, let's move to recommendation part. Number 1, consider more realistic loading scenario. In our analysis, we assume the human load is evenly distributed across the bench. In reality, people might sit unevenly or single person might sit right in the middle. This can create high local stresses at certain point, so further studies should consider this scenario to ensure safety under all conditions. Number 2, account for dynamic effect. People don't always sit gently, they might sit suddenly, shift or move on the bench. This dynamic action can produce short-term forces higher than static weight, affecting stress and deflection. Including dynamic loads in future analysis will give a more accurate picture of bench performance. Number 3, include environmental factors. Outdoor benches are exposed to rain, sun, temperature changes, and corrosion. Over time, these factors can weaken the material, reducing strength and durability. Considering environmental effects in design and analysis ensure the bench lasts longer and remains safe. Number 4, use advanced numerical methods. Hand calculations are great for preliminary analysis, but finite element analysis, or we call it FEA, can show a more detailed picture. FEA can visualize stress distribution and deflection along the entire bench, helping designers identify potential weak points that hand calculation may miss. Number 5, regular inspection and maintenance. Even a well-designed bench can degrade over time. Routine inspection and maintenance help detect issues early, like corrosion or loose connection, ensuring the bench continue to be safe and comfortable for users throughout its service life.
So all in all, for the conclusion, this study analyzed the structural behavior of a bus stop bench support using solid mechanics principle. The bench was modeled as a simply supported beam, and reaction force, bending moments, stresses, and deflection were determined using the hand calculation method. Results show that maximum bending stresses in the mild steel bench is far below its yield strength, giving a high factors of safety of 10.5. The calculated deflection was acceptable, serviceably limits ensuring user comfort. Overall, the bench support structure safe, durable, and suitable for public using under the assumed load condition, demonstrating the effectiveness of hand calculation methods for real-world structure analysis. Thanks for lending me your ears. Have a nice day.